Hello everyone, this is MD Samir. I am pursuing my graduation in IRE College as a CSC Data Science Department. In Applied Physics subject, I selected the topic Silicon p-n junction diode. I am going to explain about the silicon p-n junction diode. Let's begin. A new type of p-n junction silicon diode has been prepared by alloying acceptor or donor impurities with N or p-type silicon. The unique feature of this diode are, so first of all we need to understand about what is meant by the silicon p-n junction diode. A new type of p-n junction silicon diode has been prepared by alloying acceptor or donor impurities with N or p-type silicon. So we have to understand before this we can clearly understand the topics of PN, what is meant by junction diode. So I am going to tell everything about PN junction diode and silicon diode also. So in this we can mainly focus on 3 points. First one is reverse currents as low as 10 to 10 amperes. Rectification ratios as high as 108 1 volt. And another option a zener characteristics in which d or log 1 by d of log v may be as high as 1 500 over several decades of current of d as a stable zener voltage which may be fixed in the production process at values between 3 and 1000 volts, and e ability to operate at ambient temperature as a high 300 degrees Celsius. So I have mentioned here diagram also we can observe here donor in and acceptor in p-n junction diode. So what is meant by p-n junction? A p-n junction is a boundary or interference between two types of semiconductors materials p-type and n-type inside a single crystal of semiconductor. It is created by a doping. So I can give here electronic symbol. The triangle shows indicated the direction of current p type n type. So we can observe here the direction shows the direction of a current. So in first square box we observe p type and n type, the distance between two this as a square shape, I mean rectangle shape, that is a depletion region. Formation of a depletion layer. The excess electrons in the n region cross the junction and combined with the excess holes in the p region. N region loses its electrons become positively charged. P region accepts electrons becomes negatively charged. At one point the migratory action is stopped and additional electrons from the n region are repelled by net negative charges of the p region. Similarly, an additional holes from the p region are repelled by the net positive charges of the n region. So, finally, the net result is a creation of a thin layer of each side of the junction which is depleted emptied of the mobile charge carrier. This is known as a depletion layer. That is the thickness of the order, that is 10 to the power of minus 6 meter. When we are going to solve the problems, this value is needed. So mobile charges carriers but only fixed and immobile ions. Its width depends upon the doping level. Heavy doped thin depletion layer, lightly doped thick layer depletion. And next, potential barrier. What is meant by the potential barrier? The electrons in the n region have to climb the potential hill in order to reach the p region. Electrons trying to cross from n region to p region experiences a retrading field of the battery and therefore repelled. Similarly, for holes from p region, potential thus produced are called the potential barrier. So simply, potential thus produced are called the potential barrier, that is germanium 0.3 volt and silicon 0.7 volts. In PN junction can basically work into two modes. A battery is connected to the diode, that is the forward bias mode and reverse bias mode. In the forward bias mode, positive terminal connected to the P region and negative terminal connected to N region. In the reverse bias mode, negative terminal connected to P region and positive terminal connected to N region. So we can see now forward bias PN junction. It forces the majority charge carriers to move across the junction, decreasing the width of the depletion rate. So we can observe here the PN junction diagram, anode and cathode. Once the junction is crossed, a number of electrons and the holes will recombine. For each hole in the p section that combines with an electron from the n section, a covalent bond breaks, an electron is liberated which enters the positive terminal, thus creating an electron hole pair. Current in the n region is carried by electrons, current in the p region carried by holes. So this is the important point we have to note. Current in the n region is carried by electrons and current in the p region is carried by holes. Next, reverse biased junction. If the positive of the battery is connected to the n type and terminal to the p type, the free electrons and the free holes are attracted to back towards the battery, hence back from the depletion layer, hence the depletion layer grows. Thus the reverse biased p-n junction does not conduct current. Thus p-n junction diode allows the electrons flow only when p is positive. This property is used for the conversion of AC into DC, which is called the rectification. So this rectification is very important. We can observe this property is used for the conversion of AC into DC, which is called the rectification. AC into DC. So we can observe here one of the graph I have mentioned, that is the forward bias and the reverse bias. I can mention here current in the vertical and volts in the horizontal, VR and IR, that is the forward bias and the reverse biases. So this is the diode characteristics. So in the PN junction, what are the advantages? This is very important because we use the PN junction to use for the advantages. What is that advantages? First one, no filament is necessary. In the PN junction, no filament is necessary. We are using the light bulbs in our homes, which is made up of the tungsten. But here filament is not required. Occupies less space. So this is the most useful advantages because it occupies the less space and long life. So everyone need this. That is a long life we can use. So we can observe PN junction, anode, cathode, and the P region and the N region, and here one of the battery. So another applications as rectifiers to convert AC into DC, that is the rectification, as a switch in computer circuits. So in the computer circuits also we use as a switch, as detectors into radios to detect the audio signals, as LED to emit different colors. So we have know about the LED, light emitting diode. For emit the different colors we use this PN junction diodes. In the computer circuits also we use the PN junction diode circuits. And next, mostly important, we can focus on the forward biases and the uh, reverse biases. So in all the junction, this is important, positive terminal connected to P region and negative terminal connected to N region. In the reverse biases mode, negative terminal connected to P region and positive terminal connected to N region. So this is the most important. And another thing, potential barrier. So that is the value here is given germanium and silicon. Germanium is 0.3 volts and silicon is 0.7 volts. And we have to remember heavy doped, that is a thin depletion layer, lightly doped thick depletion layer. And N region loses its electrons become positively charged, P region accepts the electrons become negatively charged. So we have to remember electronic symbol, that is triangle shows indicated the direction of current because we have applied the current in this PN region, it shows the direction of a current. So this is about the PN junction diode. We can observe all main topics and we can conclude our topic by applications once again. I can read here as first thing, no filament is required, occupies less space and long life, as rectifiers to convert AC into DC, as a switch in computer circuits, as detectors in radiation to detect the audio signals, as LED to emit the different colors. So in most of the exams also they are asking about the PN junction diodes and their diagrams and questions also. So we have to focus on the